Welcome back. In this video, we'll be defining basis and doing one example. Consider a vector space V. A basis for V is a set of generators, we'll usually call the set B, for V without any redundancies. This idea is made mathematically precise in the next definition. Note that since every subspace is also a vector space, we can talk about a basis for a subspace of a vector space. All right, let V be any vector space. This should not be here. A subset B for V is a basis for V if the following two condition holds. First of all, B needs to be a set of generators. So span of B should be all of V. And second, I don't want any redundancy, so I need B to be linearly independent. All right, first example, let's call the standard basis for En. I'm going to take the generators Ei to have all zeros except in the ith spot. In the ith spot, I'm going to take 1. All right, so I want to show that E1 through En is a basis, so I need to show the two conditions. I need first to show that it generates all of En. So take W, I'm going to take it to be x1, xn in En. Then I'm going to show W's in the span by writing it as x1 times 1, 0, 0 plus x2 times 0, 1, 0, blah, 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 and then xn times 0, 0, 0, 1. And so I have x1 E1, x2 E2 plus xn En. Bit tight, so let's put it here. All right, so I managed to write W as a linear combination of my basis, well, my generators. So this is a linear combination of E1 through En, and so that means that W is in the span of E1 through En. But that's true, it was a random element, right? I didn't pick it to be special in any way. So any element of En is also in the span of B. And so all right, second thing we need, so we proved this one. We also need to prove that this set is linearly independent. I'm going to start with a combination giving 0. So assume if I actually put these elements together, I'm going to get A1, A2, AN. And so if this is equal to 0, that means I need A1 to be 0, A2 to be 0, and AN to be 0. So the only solution for the usual system is the trivial one. And so that means that B is linearly independent. All right, so in 1, I prove its span. In 2, I prove it's linearly independent. So together, I get that B is a basis for En. All right, so that's all you have to prove, linearly independent and spans your vector space. Let's put in a definition. This specific basis for En is called the standard basis. It's the most natural one for En, so we'll refer to it once in a while. All right, that's it for this video. We'll do more examples in the next.